Hello there, this is a geometry video. It's chapter 8, section 5, and today we will be using what we've learned in the previous lesson about trigonometry and apply it to angles of elevation and depression. And this does not mean that it's a therapy class. I know it says depression there, but that is just what they call these angles. So before we can get started, I want to make sure that you understand what an angle of elevation and an angle of depression is. All right, so technically an angle of elevation is the angle that is formed by a horizontal line and an observer's line of sight to an object above the horizontal line, which sounds really complicated. And then to go further, the angle of depression is the angle formed by a horizontal line and an observer's line of sight to an object below the horizontal line. So it just sounds very confusing. But when we say horizontal line, that's kind of what this is here. So here I've made a little diagram. Here's your observer. Here's a little person here. And their eyes are basically the line that's horizontal here. And so this person is looking up. So hence the elevation, you're looking up. So the angle of elevation is made by the horizontal line that comes from the person's eyeballs as they look up towards an object, and this black line represents the line of sight. Okay, so then the angle of depression is basically, depression means you're looking down. So suppose that instead of being down here, you were standing up here, and then you were looking down towards the person. So here's the object, and here's the horizontal line again, and then the line of sight, and this time it's an angle of depression because you're looking from above below, so it's down. The interesting thing about this is that both of these red lines are horizontal lines, they're parallel lines, and the line of sight actually ends up becoming somewhat of a transversal, and you can see that the angle of elevation and the angle of depression are alternate interior angles, and therefore actually the same angle measure. But just want to give you an idea so that you know what an angle of elevation is and what an angle of depression is, because you need that to be able to apply it to the problems today. So in example 1, I've already drawn a diagram, but we want to focus on the actual question, and then you can see why I drew the diagram the way that I did. It says Leah wants to see a castle in an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. So here's Leah, she's standing right here, she's got her horizontal and her line of sight, and so basically the castle is up here, the top of the castle anyway, and so her line of sight is right here, and it makes an angle of elevation of 38 degrees. So that would make this angle 38 degrees. She knows that the castle is 190 feet tall. If Leah is 5.5 feet tall, how far is she from the castle to the nearest foot? So basically what's happening there is we know that the castle is 190 feet. They're both standing on the same surface of 190 feet, of the ground, but Leah is 5.5 feet. So this horizontal line is actually 5.5 feet above the ground, and the castle is on the ground. So we want to take 190 and subtract 5.5 feet from that so that we can have the right number here. And so 190 minus 5.5 is going to give us 184.5 feet. So I wanted you to understand why I did that. But now all we're looking at is basically a right triangle, and we can apply what we learned in our previous lesson to solve the problem. It says how far is she from the castle to the nearest foot. So the distance that they're asking us to find is this distance here. How far is she from the castle? And that's why I put X there. So we're dealing with a triangle. Here's my angle, and I'm given the opposite side, and I'm given the, well, I'm not given the adjacent side, but I'm being asked to find the adjacent side. So the hypotenuse doesn't really have any play in this problem. So because of that, I'm not going to use sine, I'm not going to use cosine, I'm going to use tangent. So I know that the tangent of the angle, in this case the angle was given as 38 degrees, the tangent of 38 degrees is equal to the opposite side, which is 184.5, divided by the adjacent side, which is x. And now my job is to basically solve for x. Remember that when you're doing these problems, you want to make sure that you're in degree mode. So before you even go any further, if your calculator is already in degree mode, make sure it's in degree mode. And now to solve this little guy, you can make it into a proportion. And we have x times tangent 38 is equal to 184.5. A lot of times students try to multiply both sides by x, which is totally fine. That isn't a problem. The problem is that sometimes when the x is on the top, they try to divide by x and they cancel it all weird like. So you don't have to make a proportion if you don't want to. You could have times both sides by x and you would have gotten the same thing. But I like to have people use the proportion method because it will cause less problems later when you have the functions inverted, which probably doesn't mean anything to you right now, but just so you know. All right, so now to solve for x, I need to divide by tangent of 38 degrees, which again is a number. But to get the exact answer, I don't want to figure out what tangent of 38 is until the very end of the problem. So now I'm there, and I'm going to go 184.5 divided by tangent, and when I hit the tangent button, automatically a parenthesis opens up. 38, close that parenthesis, and then hit enter, and I get 236.15. But again, this said to round it to the nearest foot. So because it's 0.1, I'm going to round to the nearest foot, which is basically 236 feet. So Leah is 236 feet from the castle. Alrighty then, so now you can try this do-it-yourself question, and then we'll go on to our next example. It says, a search and rescue team is airlifting people from the scene of a boating accident. So again, I have a diagram, but I want you to kind of understand what's happening in the problem, and I can tell you kind of why I drew the diagram the way I did. So here this H stands for helicopter. And so it says that they're airlifting people from the scene of a boating accident. So this is where the scene of the boating accident is. But when they're doing that, they're airlifting this person. When they do that, they spot another person in need of help. Ta-da! Person in need of help. If the angle of depression, so they're up here, they're looking down, so that's why we got this line here to show you the angle of depression is 42 degrees to that other person. And the helicopter is 18 feet above the water. So here's the water, and here's 18 feet above the water. What is the horizontal distance from the rescuers to this person to the nearest foot? That's where we want the X here. So now we can get started. Because this angle is 42 degrees and these lines are both parallel, and here's our transversal, it also means that this little guy is 42 degrees. So now I have, again, an angle, and I have the opposite side, and I need to figure out the adjacent side. So again, the hypotenuse doesn't really have a play in this problem. So I'm going to go with tangent again, and tangent of 42 degrees is equal to the opposite side, which is 18, over the adjacent side, which is x again. And so we basically have a very similar situation to our previous problem. And we're going to get x, well, if my pen will work with me here, we're going to get x times tangent of 42 equals 18. There it goes. A little bit of delay there. Then we're going to divide by tangent of 42 on both sides. So x is going to equal, and they want it to the nearest foot again. So 18 divided by tangent 42, make sure your calculator's in degree mode, and we get 19.99. Waiting on my pen here. But we're going to round that up to 20 because they want it to be the nearest foot. So 20 feet. All right. The horizontal distance between the rescuers and the person that needs help is 20 feet. So there again, we see how we use our trigonometry to solve the right triangle. So now we have you try this do-it-yourself question. And then we're going to go to our last example. And we got a little bit of stuff happening here, so let's explain why this diagram looks kind of crazy. But it says, to estimate the height of a tree she wants removed, Mrs. Long sights the tree's top at a 70-degree angle of elevation. So basically here is Mrs. Long, and here's her line of sight, and she sees the top of the tree up here at 70 degrees angle of elevation, looking up. But then she's standing right here, and the tree is obviously in front of her there. Okay, so then she steps back 10 meters, and that's kind of what this distance here represents. From this point where she was, she now steps back 10 meters. That's why it says 10. So the 10 only represents the distance between the two people, which is the same person, just here she was first, and then she stepped back. Okay, so she sights, so when she does step back those 10 meters, she sights the top at a 26-degree angle of elevation. Okay, so first she had sighted it at a 70-degree angle, but now she's at a 26-degree angle of elevation. If Mrs. Long's line of sight is 1.7 meters above the ground, so again, she is 1.7 meters tall, and that's how tall she's above the ground. How tall is the tree to the nearest meter? That is the question. So we actually have to set up our equation twice, all right? And what we're seeing here is that after we're all said and done, we're going to actually have to add the 1.7 to our height, because she's above the ground here, okay? So here we go. We're going to start with this first triangle right here, this smaller triangle. And we're going to use tangent again. So I'm going to say tangent of 70 degrees is equal to the opposite side, which I'm calling x, which is basically the height of the tree, and y is the adjacent side. So you get that. Tangent of 70 degrees equals x over y. Now to solve for x, you're just going to get a proportion here. So we're going to get x is equal to y times the tangent of 70 degrees. And we're just going to leave it at that for now. X is equal to y times the tangent of 70 degrees. Then we want to take the other, so there's two right triangles here, right? There's this little one here, which we just did, and now I want to take the big triangle. And that might look a little bit scarier, but it's not going to be a big deal. I'll do that over here. So we're going to say tangent, I wanted a different color there, but it's not working with me there, so let's try this. There we go. Tangent of 26 degrees this time is equal to x, so the opposite side here is still x, but this time the adjacent side is 10 plus y. Okay, because the adjacent side is all of this plus this piece, which we don't know what that is, but we're calling it y. So tangent of 26 degrees is equal to x over 10 plus y. All right, so now what we'll do again is we're going to solve for x. So we're going to get x is equal to 10 plus y, in parentheses there, times tangent of 26 degrees. Now it gets interesting. So now that you have this, we know that x equals 10 plus y over tangent 26, and x also equals y times tangent 70. So at this point, what we can do is we can equate the two. They have to be equal to each other because they're both the same x, so they have to be equal to each other. So now we're going to equate them, and we're going to get y tangent 70. Okay, so I'm going to take y tangent 70, and I'm going to make it equal to, and this time what I'm going to do is I'm going to distribute the tangent 26 to the 10 and the tangent 26 to the y. So I'm going to get it equals 10 tangent 26 plus y tangent 26. Okay, so I've distributed the tangent of 26 to both the 10 and the y. That's important to do. All right, and now what I want to do, like in any good solving process, is you want to put the variable on the same side. There's no variable here, but there's a variable here. So I want to move this y tangent 26 to the other side. So I'm going to get y tangent 70 minus y tangent 26. I'm going to subtract the y tangent 26 to the other side, and then it's going to be equal to 10 tangent 26. Waiting for my pen to do its thing. There we go. Okay, and now because they both have a y in them, we're going to factor out the y, and you're going to get tangent 70 minus tangent 26, okay, equals 10 tangent 26. All right, so all that happened here is they both have a y, and so that's the same thing as saying 5y minus 3y. You would take 5 minus 3, the coefficients of the y's, and then put the y there. 5 minus 3 is 2y. Most of us wouldn't do it in that way. We would just know 5y minus 3y is 2y. But technically, you are factoring out the coefficients. That's all I did here. You have y tangent 70, y tangent 26. So I took the y out and left the tangent 70 minus tangent 26. The problem is that we don't know what tangent 70 and tangent 26 are. So it doesn't look as clean as the 5y minus 3y, but it is in fact the same thing. So now what we can do is divide by tangent 70 minus tangent 26 on both sides. And then we can throw all this into the calculator and have our final answer. So y is equal to 10 tangent 26. So we're going to go to the calculator and go 10 times tangent 26, close the parentheses, divided by, and it's very important that you put all of this in parentheses. So divided by, open parenthesis, tangent 70, close parenthesis, minus tangent 26, close parenthesis, and we get that y is approximately 2.158. But it says how tall is the tree to the nearest meter. Okay, now y is not how tall the tree is. That's the x value. Okay, so the x is going to equal y tangent 70. So it's going to equal to this 2.158 times tangent 70. So again, to our calculator, we're going to take, I already have the answer from previously, so I'm going to go times, answer times tangent 70, and I get 5.93. Okay, but to that, I'm going to add the 1.7 because this is just the distance from her line of sight, but we need to add the 1.7 meters of her height. So at the end of the day, plus 1.7, we get 7.63, or if you round it to the nearest meter, it's going to be 8 meters tall. Our tree is about 8 meters tall. So I hope that made sense to you. So now we're going to ask you to do this do-it-yourself question, and once you have completed this question, you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.